Welcome to aminacademy.com. In probability, let us discuss and define some important terms in probability. First one, sample space. A set of all possible outcomes of a random experiment. Sample space of a tossing unbiased coin is S equal H and T. H is head, T is tail. Now trial. Each repetition of the experiment, we have to try to get a head on by tossing a coin for one or several times. Suppose we are tossing a coin. If head we get, then stop it. If not getting head, we have to repeat the experiment. Like that, our aim is to get tail. You have to start tossing up to getting a tail. We have to continue the trial. So this trial continues up to getting a what we need it. Next one, event. A subset of a sample space is, for example, here H and H is an event when tossing an unbiased coin twice. Suppose you are tossing a coin twice, we are getting possible to get equal HT and TH and HH or TT. These are four outcomes. In that, each set is called a subset of the original sample space. Here HT or TH or HH or TT. Here, for example, we define here HH is a subset of total sample space. Next one, equally likely events. Two or more events are said to be equally likely if each one of them has an equal chance of occurrence. By tossing an unbiased coin, getting head or tail are equally likely events. Both have 50% chance to get. Mutually exclusive event. Two or more events are said to be mutually exclusive if the occurrence of one event not prevent the occurrence of other event. For example, if you roll an unbiased die of 6 faces, the 6 possible outcomes are mutually exclusive, since 2 or more faces cannot turn up simultaneously. If A and B are mutually exclusive events, then A intersection B is null set, which means when you toss a unbiased die, there are 6 faces are there. So suppose if you get one, it is not prevented by other faces. Suppose every faces we are getting is individual chances, so other face will not affect. That means other numbers, getting other numbers will not affect the particular number. Exhaustive event. Next one, events E1 comma E2 comma E3 dot 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 up to En are exhaustive events if their union is the sample space. Means each subset together gives total sample space. Next one, complementary events. If E be an event like 2, 4, 6 and E dash, which is equal sample space minus E, which is equal 1 comma 3 comma 5, is called complementary event of E, where S is a sample space of 1, 2, 3, 4, 5, 6, which means if you throw a unbiased 6-faced die, we chance to get is 1, 2, 3, 4, 5, 6. Suppose our aim is to get an even number 2, 4, 6. That is, we let it is an event E. Here E bar is total space sample space minus E, which is 1, 3, 5, which are odd numbers. Sure events. The sample space of a random experiment is called sure event means total sample space is a sure event. Getting head or tail is a sure event by tossing an unbiased coin, which means if you toss a coin, there is a chance of getting head or tail. There is no other chance is there, like 1 2 3 4 5 6. There is no number such that. So the sure event is getting head or tail. Impossible event. An event which will never occur is an impossible event. For example, getting 7 by rolling an unbiased die which are numbered as 1, 2, 3, 4, 5, 6. Here there are 6 faces only. Therefore, you can say getting 7 is impossible. So it is denoted by null set. Next one, favorable outcomes. The outcomes corresponding to the occurrence of the desired event are called favorable outcomes of the event. For example, getting an even number by rolling a die. Here our aim is to get a even number. So suppose the event we are getting 2, 4, 6 is a sure event we defined. We have done.